So let's talk about going between degrees and radians and degrees. So 360 degrees, which is one full revolution around our circle, is 2 pi radians. So half of a revolution around our circle would give us that straight angle of 180 degrees, which is only pi radians. So if I want to convert from degrees to pi radians, I would multiply my degrees by pi over 180 radians. And I got to that by taking both these sides and dividing by 180. So 1 degree is pi over 180 radians. I could do the opposite, right? If I wanted to figure out how to convert from radians to degrees, I could go ahead and multiply both sides, but divide both sides by pi. I gotta get my pencil back. Divide both sides by pi. Pi day is coming up, and that would give me pi over 180 degrees is 1 radian. So let's practice converting from degrees to radians. Remember that 1 degree is pi over 180 radians, and 1 radian is 180 over pi degrees. I like to write out my conversions. That helps me keep things organized. So let's convert each of these angles from degrees to radians. So I have 45 degrees. 45 times pi over 180 radians equals 45 pi over 180, which simplifies to pi over 4 radians. And if you aren't comfy with fractions, we got to get comfy with fractions real quick, right? We're going to use a lot of fractions when it comes to working with degrees and radians, especially when we start talking about the unit circle. So if I have 210 degrees, that's 210 times pi over 180, which gives me 210 over pi over 180, which gives me 21 pi over 18. And then I see, okay, they're also both divisible by a factor of 3. So I get 7 pi over 6 radians. We can also have negative degrees, right? Remember, that's when we go clockwise from our initial ray. So I have negative 60 equals negative 60 times pi over 180, which gives me negative 60 pi over 180, which is negative pi over 3. Last but not least, I have 100 degrees. I'm going to take 100 times pi over 180, and that's going to give me 100 pi over 180, which is 50 over 90, 50 pi over 90, so 5 pi over 9. Quick note that if we wanted to convert this to a decimal, we'd take 5 times pi divided by 9, where pi is 3.14. Now that's what I'm going to be using in class. Your text, I don't think it has listed what it would prefer, and if you use pi in your calculator, it has way more decimal places, but I wouldn't go any more than 4 decimal places because that's all I can remember, and I feel like anything else is overkill. Again, the solutions are in the PowerPoint. Next, let's practice converting between radians to degrees. So remember that 1 radian equals 180 over pi degrees. So I'm going to take 5 pi over 6 times 180 over pi. Our pi's are going to cancel. I get 5 times 180 over 6, which gives me 150 degrees. Next, I have negative 2 pi over 3 radians. I take negative 2 pi over 3 times 180 over pi. That gives me negative 360 pi over 3 pi, which would give us negative 120 degrees. And then if I have 2.5 radians, we still just take 2.5 times 180 over pi, which gives us 450 over pi, which is like 3.14, right? And that would give us about 143.25 degrees. So let's talk about some common angles in degrees and radians. So 0 degrees or 360 degrees, that's going to be 0 radians or 2 pi radians. We already saw that 45 degrees was pi over 4, 90 degrees is pi over 2. That makes sense. Pi is 180 degrees. 3 pi over 2 is 270, right? We're all the way 3/4 of the way around our circle. So we need to get really comfortable converting between the two. We are going to be working in radians a lot this semester.